Hi, this is Math 8, Unit 8, Lesson 1, looking today at the areas of squares and their side lengths. So first of all, we're going to begin by investigating the squares and their different side lengths here. And so the first thing says, which shaded region is larger, and explain your reasoning. So as you take a look at these two different shapes here, really what you want to talk about in your class as you're warming up today is just decide which one do you think is larger and why do you think that might be the case. And so as you look at that, it's different ways to look at it. You don't really have in this one any full squares that are shaded in, where here you definitely have one that's fully shaded there. But you do notice that you do have parts of squares, right? They get chopped up this way. And so you could almost imagine, if you wanted to, if you were to use some tracing paper, some patty paper of some sort, you probably could play with these shapes to reconstruct some squares that are broken up here. Right? So if you were to take this little space triangle right here and maybe rotate it and flip it over there, would it fit into that space? And again, this is not what you're having to do here, just warming up, but just as an example, let's just see what would happen if I took that little triangle right there, which is the same triangle that's here and on the other sides. What happens if I rotate that into that position? When I do that, what we notice is that we actually fill up an entire square. And so we get the full square there. So this piece and this piece is actually one full square, isn't it? Right? So combined, I actually have right there, those two combined make one. When I combine these ones, I can get another one. When I combine these ones together by rotating it there, I get a third square. I rotate that one there, I get 4. And so that actually has an area of, in a sense, 4 units. Okay? And if we look over here, I could do the same kind of thing over here. I know I have a full one there, but again, I could rotate this one and fill in that space there. I could rotate this one and fill in that space, rotate this one and fill in that space, and rotate this one and fill in that space. And by doing that, I end up with not just 1, but this one becomes a 2 when I put this together. Put those together, I get 3. Put those together, I get 4. And put those together, I get 5. And so in terms of which one has the larger shaded region, we would then say that most likely B has a larger shaded region, because this has 4 units shaded and this one has 5 units shaded there. So that's part of what we're looking at today, is these areas of squares and their side lengths. And so you can see how you can take apart the pieces and put them back together in a different way to create the square units you're talking about. Now that's helpful when we start moving into today's activity, today's lesson. When the first one here is called decomposing to find area. Okay. So find the area of each shaded square in square units. That's the first idea here. And so we have 3 different ones we're going to look at. We have this one that has the grid. We also have this one that has a partial grid, and the one down here that has no grid whatsoever. Let's take a look at the first one. All right, the first thing I notice is I see that I have a large square that encompasses this shaded region here. This large square is at a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and because it's a square, we're going to go 10 down as well. And so we have essentially a 10 by 10 square on this outline part right there. Okay, so if you take a look at this outline part, this is a 10 by 10 square, meaning that if I was to count up all the squares inside of that region, 10 by 10, I would have 100 squares. But we can tell by the picture that we're not using all the squares that are there. And in fact, we do have a chunk that we're not using at all. I have this little triangle section that goes from here down to there, and it goes all the way to this one right there and out there. We can see this triangle section definitely has a height of 1, or sorry, it has a base, maybe we call it the base of 1, and it has a length here of 9. Right, it goes out to that spot right there. So it's a triangle, in a sense, looks like this. It's a 1, 9 triangle, and I do have 4 of those. If I was to find the area of that triangle section right there, perhaps what I would look at is I would say, well, to find the area of a triangle, I do 1/2 of the base times the height. In this case here, my base is 1. It's 1/2 times 1, and my height is 9. So 1/2 of 1 is 1/2, and 1/2 of 9 becomes 4.5, or 4.5. So if I was to combine all of these triangles and these parts of a square together, I'd find that I end up with kind of 4.5 is what's inside of there, which is also true of this space here, 4.5, 4.5, and over here 4.5. So if you count them up, how many 4.5s do I have? Well, I have a total of 4. So let's multiply that to see what that's going to come out to be. 4.5 times 4. And so we have, this becomes 22, 16, and then 17, 18 is what I have right there. Okay? So I have 18 in that space. So these triangles. So if I was to take all these, I keep saying triangles, if I was to take all these portions of the squares and combine them together, I'd end up with 18.0. So let's take this number though, because that's the part that's not going to be included, and let's subtract it from the number that I do have, right? And so what I do have is I have 100 minus 18. When I do that, I end up with 82. Okay, so the region that's going to be shaded there is going to be 82, and that's what we have right there. That's the amount of space that's in that section right there. I do want to check my answer key real quick, because I wrote two things down. I want to verify I'm giving you the right solution there, because I noted a couple different ways. Just want to verify. Let's see which lesson we are in. Lesson 1, activity number 2. Yep, and we're good to go. Perfect. So 82 right there. Awesome. So the only tricky part in this one, if you're doing it on home, is that making sure this goes out to 9. That length there is important. One of the first times I did it, I just did by 10, and that's why I got a different answer. But that goes out to 9, so that's what we have right there. Let's look at the next side, because the next one doesn't have all the same lines on it, but it's definitely very similar, right? Once again, what we see is that we again have a large square here that the shaded square is inside of. This large square is a distance again of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 by 10. So we know we have a large square, it's a 10 by 10, which is 100 squares inside of it. But I need to take out these triangular parts right there. Again, to find that triangular piece, I could take a look at it, and there's a couple ways. I could say that I have a 5 and a 5 as my base and my height of a triangle, and I could find the area of that space there. Okay, this is one way. 1/2 the base, which is 5, times the height, which is 5, and I'm going to do that 1, 2, 3, 4 times. So I'm going to find the area of that triangle and multiply it by 4. Well, 5 times 5 is 25, right? And half of 25 is going to be 12.5. Because it's multiplication, the order here really doesn't matter for how I do that. I think I would prefer, just as a way of multiplying this out, I'm going to go ahead first of all and multiply 1/2 times 4, because 1/2 times 4 becomes 2. And then I have 2 times 5 times 5. And 5 times 5 is 25, times 2 is 50. So these triangular shapes altogether have an area of 50. So when I subtract 50 from the 100 that I started with, what's left on the inside is going to be 50 units. That's what's left right there. All right, so that's why I'm thinking about it. If you thought back to one of our first, on the first kind of warm-up activity, you also recognize that this is a 5 by 5 triangle with a right angle there, as is this one. If I group those two triangles together, what do I end up with? I end up with a pairing that looks like this, which is simply a square, isn't it? So I have one square there and one triangle there makes a square, and I do that 2 times. So what I end up doing is I end up having 2 squares that are 5 by 5, and as an area, 5 times 5 is 25, 5 times 5 is 25, and because there's 2 of them, I still end up with 50. So depends on what you want to see and do. The triangle way works pretty simply, right? And then I just know how many of those I'm going to be doing. Either way, you're going to be subtracting these triangle parts from the whole to see the shaded region that's left. Let's take a look at the next one here, and let's see which way you want to do. This one here, I'm going to do it by putting the triangles together to make a square or rectangular shape, okay? So the whole, once again, is a 10 by 10. So again, 10 by 10 is 100. Now I have these pieces. I have this triangle piece like this. That's a 7 by 3. And I could group it with this one right here. That's also a 7 by 3, right? So if I snap those into place there, I end up with this rectangle like that. And what is the area of the rectangle? It's length times width. 7 times 3 is 21. And we get to do that 2 times. So 21 times 2 is 42. So all this area right here combined together is going to be equal to 42. So let's subtract 42, subtract the white part from the whole thing, and that leaves us with the shaded region there. So 100 minus 42 is going to be equal to 58. So the shaded region right here is going to be equal to 58 units. All right, so that might be a little easier way than trying to work with a fraction with a triangle. I want to just do both so you can see how that works out. Up to you which way you want to do it, but this is going to become the pattern we're going to have for several more lessons. All right, so moving on. I'm going to go ahead and skip this first one here. The Are You Ready for More? I'm going to move past that. We didn't do that today. And let's go into the estimating side lengths from areas. And again, this is estimating side lengths from the areas that we're given. So we're kind of working the other direction. So what is a side length of square A and what is its area? Well, this one's not too hard to do. We just can count it out and we can recognize that for A, it's 1, 2, 3, 4, 5. So our side length is equal to 5. And I just write SL for side length. Nothing fancy. It doesn't really mean anything more than I just wrote it like that. Okay? And the area is going to be the length times the width, 5 times 5, which is 25. Okay, and we can say 25 units squared if you wanted to. That'd be the proper labeling there, because we're 5 by 5. Now when we take a look at this next one, I don't have the lines that line up the right way. You might be tempted to say, well, that's about 1, about 2, about 3, but it doesn't work that way. So let's go back to what we did before. Let's draw in the rest of this shape to show where the larger square is going to be, and then from that we can then subtract these little red triangles that are in these spaces right there. Does that sound okay? So that's the idea. So just like we did it from the last activity, now we're going to extend this square to make it a little larger in order to figure out what that side length is going to be. So I know that I have, in total, I have a square that is going to be, first of all, I have a 1, 2, 3, 4, 5, 6, 7, right? So I have a 7 length there in that square right there. That's B. Oh, sorry, I wanted me to do C next, right? So let's go to C, I guess. Let's go to C. Sorry about that. So on C, I was going in order A, B, C and not reading my directions there. So let's do C. C has a length of 1, 2, 3, 4, 5, 6. So the side length is 6, and our area will be 6 times 6, which is 36. All right, so now what is the area of square B? What's the side length? Use tracing paper to check your answer to this. All right, so they don't actually want us to figure it out, but we can. If we do some tracing paper, we can kind of measure it out and see what happens. So I'm going to draw it here, and draw it here, and here, and here. Now we take that square, and if I put it on a 6 by 6, it doesn't quite work. I put it over there, it works. What's nice about tracing paper is I can just rotate it around and get it on the grid lines and see that it's actually a 5 by 5, isn't it? So here, the area is still 25 because the side length is going to be 5. I could do it with the tracing paper. I can also, though, do it the way we were doing it a second ago by removing that as well. So this becomes a 1, 2, 3, 4, 5, 6, 7. So the area of the whole thing is 7 by 7, which is 49. And if I was to snap these two corners together, what do I end up having? I have a 3 by 1, 2, 3, 4. That's my triangular shape here. It's a 3 by 4. And I do that over here to make that rectangle. And 3 by 4 is 12. And I have 2 of those. So 12 times 2 is 24. So I subtract that from what I started with, which is the 49. 9 minus 4 is 5, and 4 minus 2 is 2. So does that answer match what I have here? It certainly does. So this way works as well, and so that's kind of the idea. Let's take a look at number 4, because number 4, now we're going to have to do this method. Number 4 says find the areas of squares D, E, and F, and then it says which of these squares must have a side length that is greater than 5 but less than 6. How do you know? All right. So let's find the areas of these guys here. So what I like to do is, again, I'm going to draw in the rest of my square so I know what the large encompassing square area is going to be. and then I can subtract the triangles from inside. So on this one, I have 1, 2, 3, 4, 5, 6. So I have a 6 by 6 large square, which is 36. And now I need to subtract these triangular pieces. The triangle piece that go together, again, I can take these two right here and form a rectangle. The rectangle would be 1, 2 by 1, 2, 3, 4. So 2 by 4 there. So the rectangle would look like this if I brought two of those triangles together. And so 2 times 4 is 8. That's the area of this and that. But I do it 2 times, so total there's 16. So all these together form 16. So I'll bring that number over here and I'll subtract 16. And what I'm left with for D is going to be 20 units right there. Okay, let's take a look at E. Same idea with E. Again, I can extend my larger square here if I wanted to. And about this time, if you've done it enough, you start to realize, I don't really need the whole square. I might just need a section of it, but there's the whole square. It's fine. We're going to go 1, 2, 3, 4, 5, 6, 7 is our large square. So 7 by 7, which is 49. Now let's take a look at that triangle piece there. This one goes like that, right? And it goes up 1, 2, 3, 4, 5 is the height, and it has a base of 2. And if I take this one and that one together, I get the rectangle. 5 by 2 is 10, and we have 2 of those, right? Those go together, make a rectangle, those there. So that's 20. So we're going to put that number up here and subtract it from our whole. 49 minus 20 is going to be 29. All right, so that's the area of E. Now for the area of F, same idea. We're going to draw that there. Come across to here, come across to here, and I'm just stopping at where the vertex are for the square. That's how I know where to stop at. All right, this has a length of 1, 2, 3, 4, 5, 6, 7, 8. So we're 8 by 8, which is 64. I'll take a look at the triangular piece. I have 1, 2, 3 right there. That's one side, and 1, 2, 3, 4, 5 there. I'm going to put 2 of them together so I get a rectangle. And 5 times 3 is 15, and I'm going to have 2 of those. Those go together, and those go together, which makes 30. So we're going to subtract that from what we started with, and so we end up with 34. So the area of F is 34. The area of E is 29. And the area of D is 20. That's 20. So the next thing says, which of these squares must have a side length that is greater than 5 but less than 6? So we're looking for a side length that is greater than 5 but less than 6. That's what we're looking for. Now the way you'd figure that out would be, if the side length was 5, then your area would be 25. If your side length was 6, then your area would be 36. So we're looking for a side length that comes between these two values, which means it'll have an area that's also between those values. So 20 is too little, 29 goes in the middle, and 34 also goes in the middle. So which ones could have side lengths that are less than 5, but are less than 6 or greater than 5? We would actually say E and F would both work because their areas are 29 and 34, which fall between 25 and 36 right there. All right, so that's the lesson for today. As your summary, just as remember, we can take a square, and we can take a square that's here, and we can find out the missing parts by encompassing it with a larger square and then putting those triangle pieces together to form a rectangle that we could then subtract. So we see here the area of the shaded region of ABCD is the whole square, 121, minus the rectangle pieces, right? And they used it here by using the area of a triangle. 1/2 times 8 times 3 was 12, and they did that 4 times. So you can either do 4 triangles or put 2 triangles together, make a rectangular shape or a square shape, and you'll be just fine. All right, so pause there, get your homework done, and let's come back and check it together. All right, here we go, homework time. Unit 8, Lesson 8, Math, Grade 8. Find the area of each square. So here we go. We're going to go ahead and we're going to, first of all, I'm going to encompass these here with a bigger square. So go around like so. Okay, have that. And it's a 1, 2, 3, 4, 5. So it's a 5 by 5, which means my area to start with here is 25. But I need to subtract these triangular shapes. The triangle here is a 1 by 1, 2, 3, 4. So for the triangle, 4 by 1, and I have 2 of them there. That's an area of 4, and I have 2 triangles there, 2 triangles there. So I have an area of 4, and 4 times 2 is 8. So we'll subtract that. And so 25 minus 8 is 17. So A is equal to 17. For B, same idea. Let's draw our square that goes around it. Alright, there's our square. It has a distance of 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. For our triangular pieces here, which we're going to have 2 of them to make that rectangle, we have a length there of 2 and a length here of 1, 2, 3, 4. And again, by putting 2 together, we're going to just save ourselves a little bit of time there. That becomes an area of 8. And I have 2 groups of them. We call this A, and B, however you want to call it. So that's 16. So we're going to subtract that from the 36. So B has an area of 20. Now C, moving down here, we're going to go extend our line there, and there, and there, and there. Again, our initial is 1, 2, 3, 4, 5. So we have an area of 25. And then we have our triangle, which have a 1, 2 on the top, and 1, 2, 3 there. We do that twice, so 3 times 2 is 6, and I have 2 sets of those for a total of 12. So my area that's in this space here, these triangles there, combine to make 12. Each one really is 3, and I add them up and I get 12. So I subtract 12, and I end up with 13 for C. And then D, our last one here, is going to extend out just one, just one, just one, just one, and just one. It has a length of 1, 2, 3, 4, 5, 6, 7. Okay, so 7 times 7 equals 49. The area of our triangle, we have a 1 by 1, 2, 3, 4, 5, 6. Make sure you go to the point there, 1 by 6. Okay, so as a rectangle, it's a 1 by 6, which is simply 6. I have 2 of them, so that's going to be 12. So now we'll subtract 12 from 49, and we end up with 37. Alright, and that's the idea. Just good practice, just doing it again and again. Make sure you show your work for your teacher, okay? Number 2, find the length of a side of a square if its area is 81. So again, looking at, if I was up here and I had a square whose area was 25, I'm thinking about what 2 numbers multiply together to get 25. This is where if you knew your perfect squares, you'd have an easy time doing this. So for example, I know that 5 and 5 make 25. So for A, what 2 numbers multiply together to make 81? Well, that's going to be 9, because 9 times 9 is 81. All right. For this one, 4 25ths, a little bit different, right? So you can think about breaking that up. So 4 25ths, break it up into, a number times a number over another number times another number, something like that. So what can you multiply together to get 4? That would be 2. And what can you multiply together to get 25? That'd be 5. So you have a side length of 25 centimeters there. On this next one, 0.49. When you're working with decimals, they're a little bit tricky, okay? We can recognize that I know 7 times 7 gets me 49, right? So that's a for sure thing. I know it's going to be a 7, but let's see. If I did 7 times 7, that gets me 49, but I want 0.49, which means I want to move that decimal over 2 spots. Now normally if I'm doing multiplication, I move it over after the fact based upon what? Based upon how many decimals are in the initial equation. So if I multiplied 0.7 times 0.7, I'd have 2 behind the decimal and have to move it to 0.9. So this is going to be 0.7 right there. And m squared, going to break that apart, is simply going to be m, because m times m gets you to m squared. All right, number 3. Find the area of a square if its side length is 3 inches. So again, because we're doing a square, it's going to be the side length times the side length. So this one, 3 times 3 is going to be 9. For B, 7 times 7 is going to be 49. 100 times 100 is going to be 1, 2, 3, 4, so 10,000. 40 times 40 is going to be 16 with those, and then add the 2 zeros for 1600. And x becomes x times x, which is simply x squared. All right, number 4. Number 4, evaluate this and choose the correct answer. All right, we can do that. The first thing we want to do is when we have the same bases, like this base and this base here, all right, we can add these numbers together. See, because I'm multiplying here, just notice I'm multiplying there. I'm going to add those together. So 4 plus 6 is added. And then this part here, the numbers out in front, these numbers are multiplied. All right, so 3.1 times 2 multiplied together gets you 6.2. Keep our multiplication sign there. And then I'm going to have 10 to the, what is 4 plus 6? 10th power. And that matches choice C. Number 5, Noah reads the problem. Evaluate each expression given the answer in scientific notation. The first part is 5.4 times 10 to the 5th plus 2.3 times 10 to the 4th. Notice we're adding here. Unlike the last problem we multiplied, we're adding. Noah says I can rewrite 5.4 times 10 to the 5th as 54 times 10 to the 4th. So let's see. What's he doing? He's moving this to the right. And so he moves it to the right, then that value goes down. So that looks good. Now I can add the numbers 54 times 10 to the 4th plus 2.3 times 10 to the 4th. All right. Now that is a true statement there. Okay. So that's true. And then he has this as an answer, 57.3 times 10 to the 4th. Well, let's see if we agree with the solution. If I add 54 and 2.3, 54 plus 2.3 would look like this. You'd have 3, 6, and 5. I'd have 56.3, first of all, times, and my bases stay the same, 10 to the 4th. Okay? Now, he wants to give the answer in scientific notation. The first thing I want to point out here is that 56.3 is what he should have added when it's added up here. So my book right now had that. Your book might say 56 now. There have been some revisions, some corrections since the book was first printed. So I know that those don't match. So that's one mistake he's made, at least based upon what I see here. Your numbers might be a little different, so take a look at them. The next problem he has is that this is not in scientific notation, is it? To put it in scientific notation, I need to move the decimal to the left. When I move it that way, then the value of my exponent is going to go up 1. So this is going to become 5.63 times 10 to the 5th power. All right, so that is the correct addition part, and it's also the correct exponent value for that base 10. All right, cool. Number 6, select all the expressions that are equivalent to 3 to the 8th power. All right, well, let's start with this one first of all. This is 1, 2, 3, 4, 5, 6, 7, 8. That is definitely okay because that's what that means. That's 3 multiplied out 8 times. This one here, when I'm doing an exponent to an exponential power, I multiply those together. And 2 times 4, last time I checked, is going to be 8. So this is also going to be 3 to the 8th. That's fine. Which means this is also true because 4 times 2 is still 8. So that is also going to work out. This one, however, 8 to the 3rd is a different problem altogether. That's 8 times 8 times 8. That is not the same thing. It's not going to work out. E, which is on my backside paper, is 3 to the 6 over 3 to the negative 2. So when I am dividing exponents, like such, when I'm dividing exponents, what I end up doing is I have to subtract those, right? So that becomes 6 minus a minus 2 for the exponent power. Minus a negative becomes plus, and so 6 plus 2 is 8, so I end up with 3 to the 8th power. So E is going to be okay. And then finally choice F, which is 3 to the 6 times 10 squared. All right, this is very, very different. All right, this is I get 3 of them, or 6 of them. 1, 2, 3, 4, 5, 6. But then I have a 10 and a 10. There's no way that those 10s are the same as 2 more 3s that I have over there, is it? So that's not going to work. So A, C, D, and E are the best solutions for this problem. That's it for today, and we'll see you next time.